Every avocado you eat, every breath you take, every beat of your heart. It's all a symphony of biological data. But with so much information, how do scientists make sense of all of it? That's where biostatistics comes in. Hello everyone, welcome back to our channel CliniLaunch Knowledge Pod. Today we will be discovering how the superheroes of biostatistics turn data into discoveries. The vast world of biology generates a constant stream of information, from DNA sequences to ecological surveys. But how do we make sense of all of it? This is where biostatistics comes in. It acts like a compass where guiding researchers through this data ocean with statistical methods to unearth valuable insights. Statistical testing sits at the core, allowing researchers to test hypotheses and draw data-driven conclusions. Imagine a researcher drowning in a sea of data. Biostatistics offers a life raft, providing a structured framework to analyze this information. It helps extract meaningful patterns and relationships, painting a clearer picture of the biological process at play. Statistical testing also allows researchers to validate or challenge their initial ideas about these processes. The foundation of statistical testing lies in the hypothesis, a statement about a population parameter we aim to investigate. Now let's talk about this. Statistical tests act as the judge and jury, helping us assess the evidence for or against this hypothesis. We typically formulate two competing hypotheses. Alternative hypothesis. In null hypothesis, this is the default assumption, stating there is no effect or relationship between these variables. Whereas in the alternative hypothesis, this is the opposite of null hypothesis, proposing that an effect or relationship between these two variables exists. The statistical test analyzes the data and produces a p-value. This value represents the probability of observing the data, or something even more extreme if the null hypothesis were actually true. Lower p-values indicate stronger evidence against the null hypothesis, leading to its rejection and support for the alternative hypothesis. Every battle demands the right weapon, and biostatistics offers an arsenal of statistical tests, each tailored for specific data types and research questions. Here are some of the most frequently used tests. T-tests. These compare means of continuous data like the effectiveness of two different drugs on separate groups. Next, we have the analysis of variance, or the ANOVA. When comparing means of more than two groups, ANOVA steps in. It breaks down the total variance in the data, attributing it to differences between groups and random error. Next, we have the chi-square test. This test tackles categorical data, helping us determine if the distribution of observations across categories differs from what we would expect by chance. Non-parametric tests. Not all data is created equal. When data isn't normally distributed or doesn't meet the assumptions of parametric tests, non-parametric tests come to the rescue. Selecting the right statistical test is crucial, but it's just the first step. Here are some additional considerations for effective data analysis. We have the sample size, a critical factor for drawing reliable conclusions. A larger sample size provides more power to detect true effects and reduce the chance of false positives. Data quality. The foundation of good analysis is high quality data. Cleaning and checking data for errors and outliers are essential before applying statistical tests. Visualizing the data. Exploratory data analysis, or EDA, using graphs and charts can reveal patterns and trends that might be missed by solely relying on statistical tests. Interpretation of results. P-values alone don't tell the whole story. Consider the effect size or the magnitude of the difference and biological plausibility of the results. Statistical testing is a powerful tool for extracting knowledge from the vast ocean of biological data. By understanding common statistical tests and their applications, researchers can design robust studies and draw data-driven conclusions. Biostatistics empowers researchers across biology, transforming data into knowledge and illuminating the path to understanding. Thank you so much everyone for joining us today. If you like this video, don't forget to comment what is the next topic that you want me to talk about. And yes, do click the bell icon and subscribe to our channel.